Okay, guys, so let's get going. And we were talking about last time that cluster, a very critical component of vSphere. Then we had a discussion about the difference between the three important uh, services. Well, before that, we went for distribute switch, and after that, um, we did the lab for that. But then we talked about cluster, so it's a grouping of all the physical servers, grouping of all physical servers to offer high availability disaster recovery business continuity. And a cluster in vSphere 7 goes up to 64 physical servers. It's better to have the same hardware for all of them. Better, but some companies may or may not be able to do that. Sometimes budget restraints are there, and they cannot purchase like a lot of servers, physical servers in one fiscal year. So then they go for the rest of the physical servers in this fiscal year. So next year, obviously, the hardware could be a bit better. So hardware comes down to a bit different, and that's why then we have to take care what kind of hardware is there in the um, cluster, and it should be the processors should be at least the same. Processors should be at least the same generation if they are a bit different. So okay, so we talked about this very, very important service, and you're going to be asked in the interview about what is HA, what is DRS and FT for all those companies which have VMware, and there are so many big companies that have VMware. So it's always a cloud plus VMware skill set that the companies would be looking for. Not just cloud, although some companies would be interested in just cloud, but big companies will have VMware. So HADRS, FT, fault tolerance, distributed resource scheduler, HA. You need to prepare this before the interview as well. When does HA kicks in? When does DRS kicks in? And when does fault tolerance kicks in? So, in fact, when you're going for interview, let me know. I'll just give you a sample resume, and you can just try to put that your resume according to that. Otherwise, also Humbers is offering, I think, resume creation services as well. But try to get more knowledge about cloud plus VMware, and then I can also guide you for some interviews. Okay, so here, HA, DRS, and FT, we're going to talk. We were supposed to talk in detail about the high availability, and we started talking about and discussing what was high availability. So HA kicks in when there's a physical server crash and the machines are restarted, while the DRS kicks in when there is degradation of performance. So this is the main word you would want to remember, and that is performance degradation. That's what DRS is meant for. Uh, if there's a server crash, DRS cannot do anything. So can you use the Okay, Chris says in the chat, so can we use U as reference on applications? Yeah, sure, obviously. No problem. Just let me know which company and from which time to which. Just give your, basic information and sure, you can use me as a reference. Okay, so also try to gain as many skills. I can also add you to all my courses free and in my LMS. And you can also join the Saturday course where we're doing all kinds of labs free as well. Okay, Saturday morning classes. Yeah, here I'm going to go ahead and so dear distributed resource scheduler kicks in only when there's a performance degradation, and then fault tolerance kicks in when a physical server crashes or virtual machine crashes, and but it fails over to another partner backup passive secondary virtual machine. Anyway, we're going to be doing the labs on that, obviously. So I'm going to go ahead and try to go in detail of all those. Now, we were talking about some features of HA as well. And we're going to continue with those HA features. So I'm just going to go for HA features. HA DRS features, we can say. But so they do work side by side with each other. HA DRS features, although they are separate big services. We already talked about what kicks in at what time, but we're gonna let's explore this slash discuss features of HA and DRS. They work side by side, and but their jobs are different, and we now know that which one kicks in for what scenario, right? If I go back here, okay, I haven't really started the machine, so I'll just leave them on start. So we could start the discussion of the features of all the virtual machines. And one day, Monday or Sunday, it's gonna uh, understand that I clicked or I double clicked it. Okay, so I'll just simply resume the first one, second, third, and well, okay. Let the first three start, and then the fourth one can pursue them. Okay, so we were talking about this. Now, first of all, we're going to go through HA, and we were talking about actually scenarios where high availability will restart your virtual machine. So, what are those disasters? What are those types of disasters for which HA will actually restart your virtual machines, and why would you not want? What type of disaster would you not want the high availability or HA to restart your machines? Uh, okay, so I did explain all that there. Yeah, this was the diagram I was looking for. So, if there's a isolated environment, now those were the options there, and I was explaining that last time. So I'm just gonna move ahead from those. But for that, obviously, I need to log in first. Um, all machines are up because I suspended them, so they are back up quickly. I'm gonna go for first one. E6A1 has also resumed, and Win01 has also resumed. So I'm just gonna refresh this browser because it's going to. I'm gonna be kicked out now because I came back from a frozen state. Okay, my machine, not me. So once this is, I'm gonna go for administrator at vsphere.local. And small ABC, capital ABC, shape 1, 2, 3, dot shape 1, 2, 3. All right, guys, let me know when you want the makeup class. I'm teach makeup. Oh, just kidding. Okay, so yeah, makeup class. So tomorrow, Friday, or next Friday, whichever you know. So makeup class. Can there be a name? Anyway, so here we're talking about the features of chain. So first we create the for the Tor cluster, then we added the hypervisors there to introduce them. We introduce the hypervisors to the cluster. Then on the cluster, I click because I need to explore the features of the cluster itself. What is it offering? What's the big deal about it? So I click that, then I click configure for the cluster, and then I go for vSphere availability first. Last time we enabled vSphere availability and vSphere DRS. Um, in fact, I was saying about the troubleshooting for these services that I'm going to drag them out of the cluster and then we're going to add them back to the cluster. Why? Because the HA agents, the high availability agents, are deployed remotely from the cluster to whichever number of hypervisors have been added to the cluster. So HA, as soon as you enable the HA or high availability, it just simply deploys remotely the agents, HA agents into the physical server. But if the agents were not deployed, and last time also we checked that, so if I go to the physical server or the hypervisor or the host and the summary, and then it says that vSphere HA agent for this host has an error. So that's not really good. Uh, so then I was saying that okay, let's just remove the servers. We did some troubleshooting here as well. There was that VCLS virtual machines that actually run the cluster. VCLS virtual machines are actually saying there's insufficient resources. Remember that we also increased the RAM of the physical servers from 4 GB to 6 GB. I'm going to check that if E6i2, yes, it has 6 GB. E6i3, yes, it has 6 GB. So I did that for troubleshooting just to issue this error of the H agent could not be installed on those two hypervisors. So the last thing that I was saying was that why don't we just troubleshoot that by putting this physical server out of the cluster and then put it back to the cluster, right? So when we put it back to the cluster, um, then HA will automatically try to remotely install the agents again, right? So in case, so how do I remove the physical servers or hosts or hypervisors out of the cluster? I am doing that. I already explained because there's an error coming. I don't want this error to come that HA failed to deploy its agent. If the agents are not there, HA agents are not there, then what will happen? HA cannot provide high availability. If this physical server goes down, this machine will not be restarted. This virtual machines will not be restarted on the other hypervisor, right? So for that, HA agent has to be successfully installed. So the crashed hypervisors virtual machines should be automatically restarted on the other surviving hypervisor. So because agents are not stored, it's not going to happen. So we want this error to go away. So I'm going to simply try to, okay, what's going on here? Um, Something happened. I'm not able to click anything here. Uh, even here was popped up. Now I'm going to drag this physical server or the host out of the cluster into the center. It's going to give me this message that, hey, one or more hosts are not in maintenance mode. What is a maintenance mode? Maintenance mode is, as the word says, if you want to do maintenance on the server or you want to move the server somewhere, then you need to put that physical server into maintenance mode. So maintenance mode is where none of the virtual machines will work. You put the server in maintenance mode for the purpose of maintenance. Word says maintenance, right? What happens? Any working virtual machines either need to be moved away from the host or need to be shut down. A virtual machine cannot work on a physical server or a hypervisor that is in maintenance mode. I need to put it in maintenance mode in order to throw it out of the cluster. Right? That's the only way to move it out of the cluster in the maintenance. How to do that? Right click here, and there's a maintenance mode here. I'm going to click enter maintenance mode. Then it's going to pop up one more question here. Hey, you got some virtual machines here. Do you want to move powered off suspended virtual machines to other hosts? No. Well, those machines are not critical. First of all, this is a training environment. Second thing is, if in a production environment these were critical machines and I was gonna put it to maintenance mode, I would have V-motioned these virtual machines away from this from this hypervisor to another working hypervisor, right? First, I would have done it already, and then I would have put it in maintenance mode. We don't have any virtual machine, and if we do have a powered off suspended virtual machine, we don't want to move it away from this host. I'm just gonna uncheck that. Press OK. Even if you keep it checked and they are moved away, it doesn't matter. Off anyway. So once I put this host or hypervisor in a maintenance mode, then I should be able to drag it out of the cluster. Okay. So maintenance mode icon looks like this. Looks like this. I'm going to now drag it out, and it should work. It did. If I close the cluster, it's outside of the cluster. It's in the Tor DC now. If I close Tor DC, collapse, I can't see the server. So it's on the Tor DC level. It's outside of the cluster. I'm gonna expand the cluster again, and I'm gonna put this other other hypervisor to maintenance mode, and then drag it out of the cluster. Just gonna uncheck that. There's a lot of stuff that we need to keep in mind. Obviously, when we go through the live lab, then we understand this. And whatever T-shoot comes here, it's better it comes here instead of that. Yeah.
Connection is weak. I don't know. It's the voice cutting out.
Again, sorry. What's the question? Oh, voice is cutting out. That's what you're saying, I guess. Yeah.
I can't hear you properly.
So, guys, is my voice cutting out for everyone, or is it only for one user? Is my voice cutting out, guys? Is my voice cutting out? Mir says it's clear. Voice says no, it's not cutting out. Sinchana says no. I think then some kind of internet disruption on your side. As for other students, voice is okay. Um, okay, guys. So I have to then continue, right? Okay, okay. Guys, so I'm gonna go ahead and what I did was I I put the two hypervisors into maintenance mode, then I moved it out of the cluster, right? So once we move out of the cluster, then I'm gonna put it back. Okay, so if I click the cluster here, I mean there's some kind of red.
Sorry, Professor.
Sure.
Sorry to interrupt you. Now it's also cutting out. Now it's not clear. Rejoin the meeting, but now it's unclear as well. And my connection, it's great. No problem with my connection.
But other students are saying it's not cutting out for them, so my connection is also okay. Like, it should be cutting out for everyone if my connection is problem, right? So, but if it's good for others, then actually, not sure what to do even if it was cutting out. I mean, my internet would be totally dependent on my internet. But
It's good now. Sorry, it's good now.
sure. Okay. So guys, okay, I'm gonna sit a little near mic and okay, let's continue. So as we were talking about that, now I click the Tor cluster here, and then I go to summary of the cluster. An empty cluster now, right? There's nothing inside, so we cannot find master agent. Anyway, obviously there's no hypervisor inside, so that's why it cannot find the master agent. I'm gonna just put them back, but before that, I need to take them out of the maintenance mode. Just gonna right click that, maintenance mode, exit maintenance mode. For one more thing, you need to put them on maintenance mode, and that is when you are patching the hypervisors. Then also it requires you to put the hypervisors into maintenance port. Like driver updates, critical updates, security updates. I'm gonna click exit maintenance for both, and they pretty much quickly go out of that. The first hypervisor is okay, and yeah, it shows all that. Good. Now I'm just gonna drag it again inside. No problemo. So now here I'm going to drag it back inside because we need to discuss the next features. But there's T-shoot going on. That's the thing with the live environment that errors do happen. But the thing is, they only teach us then. Kind of a good thing. Like you get to see the errors here instead of in the production environment. Now I have dragged the first host to the cluster, and it's asking this question: what would you like to do with the virtual machines and resource pool or for this hypervisor? I mean, well, I don't have a resource pool, or even if I have it, I don't care about the resource pool. Why? Because DRS is a bigger resource pool. It takes care of the machines on a very high level, so on a better level. So it's okay. Put all of this host virtual machines in the cluster's root resource pool. Resource pools currently present on the host will be deleted. It's okay. We do not need resource pool. You know what resource pool was doing? It was reserving CPU and RAM for most critical machines. This task will be done better by DRS. We will know. So we don't need a resource pool now. So I'm just gonna press OK with that. And I drag this hypervisor into the cluster, and because if I click the cluster and I go to configure, so what I want to show you is that um, cluster configure. Um, I click the cluster. My first summary. It hasn't changed the cluster into a cluster. Oh yeah, this is what I want to show. Configuring vSphere HA. HA is already enabled in the cluster, right? So as soon as I drag the hypervisor into the cluster, um, since HA was already enabled in the cluster, so HA started putting its agent in that hypervisor. I see that now there's no error. Waiting for cluster election to complete. Okay, there's a cluster election going on. Last time we discussed about cluster election as well, that hypervisors do an automatic election between themselves, and they elect a master hypervisor, and the rest of the hypervisor are slave hypervisors. What do the slave hypervisors do? The only job of the slave hypervisors is to send alive packets to the master hypervisor. Hey, master hypervisor, alive, alive, alive. So they send it per second heartbeats. We also call it heartbeats, which are just I'm alive heartbeats. So yes, that's what the election was. I need to drag the other hypervisor into the cluster as well. If I just close the cluster, now one is inside, one is outside. One hypervisor is inside, and I'm just going to drag the other hypervisor into the cluster from the data center to the cluster. I'm dragging it, dropping it on exactly top of this, right? Okay, and yeah, I don't need the resource pool because I have DRS now. Okay, so once it goes inside, our best friend recent tasks tells us that configuring vSphere HA and 50%. Yeah. Guys, so what happened here is that also saying waiting for election and configuring vSphere HA. Now, it may start, sending its HA agent inside the hypervisors, or it may have done it already. It doesn't clearly say that here in the recent tasks area, but so far, I mean, dragging out and putting back in seems like it's working, and those errors are not no longer there. So if I go to summary, I'm already on summary and insufficient resources to satisfy vSphere HA failure work level on. So they're just saying that insufficient resources are there, but overall it seems like good now. So I'm gonna go ahead and explore the Tor cluster features, and I have clicked the Tor cluster, and I'm gonna go to configure, and there, okay, it was kind of not responding. Now it's responding. And then I'm going to go to vSphere availability. I wanted to show you all the features of vSphere availability. And last time we enabled or turned on vSphere HA, which is vSphere high availability and proactive high availability. And then we also enabled DRS. So we're going to discuss the features of these two critical services. I'm going to go for vSphere HA is turned on. I'm going to click the edit button because that's where all the features of HA are, right? So if I click the edit, it shows me this, that these are the types of disasters that can happen. And what do you want HA to do with your most critical asset? What is your most critical asset here? Virtual machines. So if these types of disasters happen, then what do you want HA to do with your virtual machines? Do you want HA to restart the virtual machines automatically or not? So some of the options is yes, restart automatically. Some of the options is no, don't restart automatically, like this, right? So host failure response is obviously this is the we went through this last week as well, so you can just refer to that. But briefly, if the host physically crashes, it will restart the virtual machines on the surviving other hypervisors. Okay, we get that. And we talked about that last time as well. Response post isolation, I had explained to you before as well. And that's what this diagram was about. So there's one switch here, physical switch 1, physical switch 2, and those switches are connected to each other. And there are 6 hosts that suppose they're connecting. 3 hosts are connected to physical switch 1, 3 hosts are connected to physical switch 2. And suppose there's no connection between the switches. So these hosts will, which were all slaves, and one master was elected already. Suppose this was a master and all other were slave hosts. So these hosts, if they're isolated and they cannot reach their master hypervisor to tell this master hypervisor, hey, I'm alive, I'm alive, I'm alive, or second heartbeat. So they will elect again among themselves, hey, who's going to be the master? Suppose this becomes a master. So then the other slaves start sending them the I'm alive packets per second. And whenever the switches have the connectivity back, then this master sends the report to the actual master that was elected earlier, and it again goes back to being slave and start sending packets. I'm alive, I'm alive, I'm alive. And master reports all that. Hey, all other hypervisors are good. Reports that to the vCenter. Feature of the vCenter. Right. The other thing is that suppose and I was explaining that last time. I'm just going to be brief and quick now. Suppose your management connection to this hypervisor is frozen. Management connection to this hypervisor is frozen, but there are multiple network cards here, and maybe there are 20 virtual machines here, and maybe there are 15,000 or 10,000 or 8,000 end users are connected to all those 15 virtual machines. They are connected through different network cards. So maybe through your vCenter to your hypervisor, the connection is frozen. You cannot do anything remotely on this hypervisor. You cannot manage it. But that doesn't mean that the whole hypervisor is frozen. It could be that the connection, only something wrong with the network card has happened, but you cannot remotely manage it. But the whole hypervisor might be okay, and end users might be connecting through other network cards to all the virtual machines. So do not go down to the data center and then just simply shut down this hypervisor because your management connection is frozen. Because It is a possibility that through other network cards, the end users could be connected there to the virtual machines. So if your management connection is frozen to the hypervisor, then another thing is confirm that the whole physical server is frozen or just one network card has an issue, and any end users are complaining to the desktop support guys. No, this means that they are still connected and you can restart this physical server or hypervisor in the evening or night or on the weekend, right? So that's another scenario to this whole host isolation. This diagram is talking about host isolation. Alright. So in host isolation, I don't want HA to touch my virtual machines. I'm going to go down to the data center and investigate myself. If I see that the whole host is frozen, and yes, there are lots of complaints coming that end users are unable to connect to hundreds of end users, thousands of end users are unable to connect to certain virtual machines, and you confirm that these are the virtual machines that were on this hypervisor that is whole frozen, but you would want to go physically to the hypervisor and confirm that. Do not let HA restart automatically your virtual machine. It could be that the whole hypervisor is frozen, and but better investigate. It could be that it is not frozen as well. Don't let HA automatically restart the whole hypervisor and restart all virtual machines and disconnect all end users. So that's a scenario of host isolation. Now, if I go back to this setting here, so in response for host isolation, disabled means, hey, HA, don't touch my virtual machines, do not restart them automatically. I'm going to go and investigate myself, so I'm going to keep it disabled. Very few administrators may actually enable it as well. Up to you, up to your experience, but these are the default recommendations by VMware itself, but keep it that way. Okay, so data store with PDL and data store with APD. Oh, what are these? So what is data store with permanent device loss, PDL, permanent device loss, and all paths down, APD, all paths down. What are those? PDL and APD. If we go there, so PDL and APD. So PDL is permanent device loss. APD is all paths down. Okay, so what are those? Permanent device loss is that if the VM's storage, VM's VM's underlying storage, right? Underlying storage is lost. What does that mean? So if we go back to the diagram, not this one actually. Okay. If you go back to the diagram, now you can see that our virtual machines are actually virtual machines are supposed to be created on top of what? On top of a LAN-based data store, right? That's the professional way to create. Never create the virtual machines on a local disk-based data store, on shared over the network disk-based data store or LAN-based data store, right? Now, what about if the permanent device loss happens or PDL happens? Oh, what is that? So this is the device, and this device actually is gone. Obviously, there's only a mapping of this. Physically, the device is here in the SAN. Obviously, this is our SAN software on a very small scale training environment. But if the SAN one crashes, gone for some, it's a physical device. Yes, disks are working 24/7, 365. They don't stop at all. So yes, ultimately they will crash, right? If they will crash, then its mapping was over the network. Physical device is actually here. So whatever the end users were saving here, they were connected and saving here. So that was actually being saved all here. Oh, but this device is no longer here. What? So what will happen is, obviously the machine, the end users have nowhere to save. This whole LAN is actually no longer available because it's just a mapping over the network. Actual disk is gone here. So what happens is the virtual machines virtual disk is not accessible anymore. Virtual machines files that run the virtual machine were also living here because they were living on the device and the device is gone. So normally what happens is if the virtual machine underlying storage is crashed, has some issues, so the virtual machine just freezes. Like end users are connected and they are clicking and click, 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 and it's just frozen. So that's the case where you would want HA to do something about it if PDL happens or permanent device loss happens. So if we go back to our options here, it says here data store with PDL. If permanent device loss happens, power off and restart VMs. Well, that looks like a logical thing to do because definitely it's going to virtual machines can't do anything if the underlying storage is gone. Pretty much you don't have much, nothing here. Maybe the device, this hard disk is restarting. Maybe the whole SAN, um, tower is restarting, and all the disks are coming back up again. Right? All the disks are coming back up again. So if the SAN suppose got restarted or the device had a glitch and it was off, then it is on now. But the virtual machine is still in the frozen state, and you were busy doing some other ticket, resolving some other issue, some other ticket. When you come back after maybe 15 minutes, half an hour, and then you see, oh, the machine was for last half an hour in the frozen state. If I had HA if I had allowed HA to restart the frozen machine by now, within maybe 5 to 10 minutes, it would have restarted. But oh, I was able to come after half an hour, and for half an hour, end users were just doing nothing because nobody did anything about it. So, do you want HA or high availability to power off and restart VMs if the permanent device loss happens? VMware recommends this, and obviously we would go for this unless you have a very good reason to properly disable it, and this means that you want to investigate yourself and then decide what to do. Yeah, if suppose you think that there are enough dedicated VMware administrators, it's a big environment, but still you think that yes, you can keep an eye on this, then it's okay to disable it. Otherwise, let HA actually power off all the virtual machines on that if PDL happens, right? So we understand what is PDL, and if we go for so permanent device loss, the SAN disk crashes, but if it uh, uh, you know powers back on automatically while the VMs on it are still in a frozen state, then it is a good idea to let HA power off and restart or restart the VMs. While you are coming to investigate, the machines are still frozen, users are still screaming. There were like 5,000 end users there, so that's a lot of users screaming. And a lot of managers will be jolted as well, and they will be on your shoulders very soon. and so better HA comes to the rescue and just restart the machines. And so here in APD, the if the VM connections, okay, so what is APD? First of all paths down, but what is that? All paths down is that um, the paths are okay. Here, I created that here, but I was supposed to create for PDL that the actual device was gone, right? That's PDL. The device was gone. But what about all paths down? So this time, device is okay, but the path going towards not okay, right? So yes, the virtual machine data is still safe here, and it's just not accessible anymore because the paths going towards the device are actually down. So in that case, it's pretty much the same thing for the virtual machines as far as the virtual machine is concerned. That end users who were saving on the virtual machines, well, where they were saving was a virtual disk. Virtual disk is on the data store is on the LAN, and LAN is actually here. Okay, itself, it's okay, but the path going towards it is down. Pretty much the same scenario. You would the virtual machine would freeze because it cannot access the storage anymore, underlying storage. End users are all screaming, virtual machines are all frozen. What do you want to do? So VMware suggests the same kind of solution here. Power off and restart VMs, conservative restart policy, and then there is aggressive restart policy. You want to take some time for the services to restart, or you want to do a quick restart. That is just the only difference here. Otherwise, yes, you would want HA to do something about it right away. So this just makes sense because 90% of the cases virtual machines freeze, but underlying hardware is no longer available, right? Okay, so that would be APD. In that case, PD, the virtual machines would still be restarted. Okay. Now we understand then that okay, virtual machines will be restarted, and what VMware suggests as a default option, we would stick to it. Up to you. You may have some other reasons you have heard from other administrators to do something else. It's up to you then. But I'm just gonna put that picture here as well for all paths down, and Brian suggestions are not coming here. Seriously. Then I'll just put it on the next one. So that's APD end. Um, no, PDL. If we go for another type of disaster, and that is VM monitoring, uh, that a disaster? Well, it kind of relates to the disaster. There is VM monitoring only, and there VM and application monitoring. So what are these two? VM monitoring and VM monitoring and VM application monitoring. So VM monitoring is all about um, heartbeats coming from the VMware tools of a VM to HA. If heartbeats stop coming, HA is supposed to start the VM, right? And VM application monitoring. Concept is same, but means that uh, an application is is configured, right? With the help of VMware support, you can talk to your company may have a contract with them with support to send heartbeats to HA. and our best beasts. Our beats HA. And in case HA does not receive uh, the HBs or heartbeats, then it restarts the VM. Both cases, VM gets restarted. Now that is kind of that same solution where maybe majority of administrators would go for, hey, don't touch my virtual machine if the heartbeat. So if we go back to the diagram here, then now the VM monitoring, the virtual machine is actually sending heartbeats. I'm alive, I'm alive, I'm alive, I'm alive, I'm alive to HA living inside VCSA, right? So HA says, thank you. Okay. Now, somehow, it could happen that yes, the whole virtual machine is not available. This means, or this virtual machine is totally frozen. In that case, it means, hey, HA, go ahead and restart the virtual machine. But it could be that the VMware tools installed inside on top of the operating system inside the virtual machine, only the VMware tools might have a problem. Which means what? VMware tools are unable to send the heartbeats while virtual machine will be still working. Now, heartbeats are not coming means HA is supposed to restart the virtual machine without obviously any investigator or anything. So many administrators think that I don't want HA to restart my virtual machine just because heartbeats are not coming. Because I would want to investigate, maybe the heartbeats are not coming because of something happened to the VMware tools itself. The whole virtual machine itself is okay, working fine, and users were connecting to it fine. So either you would prefer to investigate yourself and restart, then you decide to restart, or you let HA restart if heartbeats do not come. VM application monitoring is you actually have an app, big application here, and hundreds of thousands of users are connected here to this virtual machine. And you've configured inside the application to send heartbeats to HA. Now, heartbeat stops coming, HA will restart the whole virtual machine plus the application, and all end users will be disconnected. And it's up to you again that you want to go and investigate yourself that why heartbeats stop. Right? You can actually configure. No, it doesn't say events only. So there was an option here, issue events, right? But I was thinking that there would be an issue events, and I would select that, and it would just tell me that okay, heartbeats are not coming. I'm just letting you know. Issue events mean just that, right? Alerts come to you. But it says either you disable it or you enable it. Uh, VMware suggests the default option is disable. Go ahead, investigate yourself. Heartbeats are not coming, and then restart if needed. So it's up to you. What do you want? Up to your experience with the VMware environment. So when you become a VMware administrator and a cloud administrator, and then after some time you realize that okay, the VMware environment, this happened, that happened. You gain some more experience. You become somewhat advanced administrator, and then you can with those options and change them. So yeah, that's enable host monitoring and some of the disaster scenarios that we talked about. Other than that, there's a very, very important thing called admission control. And it's not mission control from NASA, it's admission control. So you control how much you want to admit. Just kidding. No, it's not that. It's admission control is seriously. It's not even going there. Oh, cancel this and come back again here. Huh. Yeah. Oh, thinking. Admission control is also called capacity reservation. While it is thinking, let me just tell you something about it. Admission control, which is obviously very critical, it's all about its all about capacity reservation. Oh, what is that? So, do you want to maintain the loss of one hypervisor and still everything works fine? Well, can you do you have the ability? Okay, uh, I just add or do your cluster environment have the ability to tolerate the loss of one hypervisor worth of virtual machines? You lose a hypervisor. What do you exactly lose? You lose the virtual machines running on top of it. That's the most critical asset you have because those virtual machines have the most critical application. Those applications have the most critical data that is running your company, and lots of users, hundreds of thousands of users are connected to that data. So, do your cluster environment have the ability to tolerate the loss of one hypervisor worth of virtual machines and still keep working? Um, there will be downtime. Um, Users will be disconnected, but the VMs will be restarted ASAP. So as soon as possible, right? On other hypervisors. Okay, now the main thing is what's the benefit of admission control? Again, what's the benefit of capacity reservation? Once the hypervisor crashes, once hypervisor crashes, then do the other hypervisors have enough CPU and RAM to accommodate? That's the main thing what admission control is built for. CPU and RAM to accommodate all the VMs of the crashed hypervisors. Hypervisor. Once hypervisor crashes, then do the other hypervisors have enough CPU and RAM to accommodate all the VMs of the crashed hypervisor? That's the question. That's the main thing that defines admission control. So this means that during the regular days, were you prepared for this kind of disaster? Do you prepare your cluster for this kind of disaster? That's all what admission control does. So it prepares the whole cluster. Hey cluster, hey all, suppose there are 10 hypervisors. Hey all 10 hypervisors, we need to prepare our environment in case one of you crashes and your virtual machines need to be accommodated on the rest of the 9 hypervisors. So we need to prepare now. We don't know when the crash can happen, and the crash will happen, and we need to prepare from now. So what kind of preparation it needs? It needs to save enough CPU and RAM on all hypervisor so they can all tolerate loss of one hypervisor, right? Okay. So if we go back seriously, what's going on here? Didn't recover. Refresh. What's going on? Oh, it kicked me out again. So if we go for, yeah, I'm going to go back to this, the feature here, admission control. And here it says admission control is a policy used by vSphere to ensure failover capacity within a cluster, right? Raising the number of potential host failures will increase the availability constraints and capacity reserved. In English, what it's saying is that right now it is prepared to tolerate the loss of one hypervisor worth of virtual machines. Well, we have just two hypervisors if we take our training environment. And if one hypervisor goes down, obviously its virtual machines will be restarted, are supposed to restart on the other hypervisor. So other hypervisor has its own machines plus the machines of the hypervisor it had to take. Now it says that define host failover capacity by cluster resource percentage. And here it says override calculated failover capacity, reserved failover CPU capacity 50%, reserved failover memory capacity is 52%. Now, let me explain first the other options, then we're going to go for that. What is slot policy? Slot policy is that you define that either you define or the cluster tries to know. What does cluster tries to know? Cluster tries to, or HA actually, the HA feature of the cluster tries to know how many virtual machines on average are there in each hypervisor. Average. Suppose there are 7 here, 5 here, 10 here, maybe there are 10 hypervisors. So on average, suppose the cluster checks that, or HA feature of the cluster actually checks that, hey, on average, I see that there are 5 or 3 virtual machines on average that are on every hypervisor. Okay, when it decides that, okay, I think there are 3 virtual machines on average, then it sees that how much CPU and RAM these 3 virtual machines can take or are taking on average. Again, so then it tries to know that, oh, okay, on average, this much CPU and this much RAM is needed for a set of virtual machine. Why would it want to know all this? If the hypervisor crashes, then it will, the hypervisor crashes, then HA will know this much CPU and RAM must be available across the cluster, because not all virtual if suppose these are 10 hypervisors, so and if there were 6 virtual machines here or 5 virtual machines here or 4 virtual machines here, those virtual machines, all 4 suppose virtual machines will not come on one hypervisor. One might be adjusted here, two might be adjusted here. Suppose there was more CPU and RAM here, and suppose there's one more and that would be adjusted in some other hypervisors, right? So HA tries to know that what is the average CPU and RAM needed for a typical hypervisor's virtual machines, and then it tries to reserve that much CPU RAM on all hypervisors. It divides that capacity. So it says that, hey, 30% of or 40% of CPU and 40% of RAM normally are being taken by average number of virtual machines. So it divides that capacity among all hypervisors. What does that mean? It can tell all the hypervisors, hey, every hypervisor from now on, you won't be able to use more than 80% of CPU and RAM. If you ever reach 80% of CPU and RAM, that's all you're getting, because we need to reserve 20% of CPU and RAM for the possibility that one of you might crash, one of the hypervisor will crash, and its virtual machine we will have to accommodate. So I actually will not let you use more than 80% of CPU and RAM. And I'm going to reserve 20% CPU and RAM on all hypervisors. So 20, 20, 20, 20, they will all be not using 20% of CPU and RAM, and their total will be only 80% available. In case hypervisor crashes, virtual machines will be vMotion, not vMotion, restarted to the other hypervisors, and there will be short capacity of 20% CPU and RAM will be available. This means at least one virtual machine will be accommodated on each hypervisor. Right? So this is called capacity reservation. And obviously, this is a very, very critical feature. So slot policy, now you know that suppose you're a big shot administrator and you say that no, I don't want VMware to or vSphere to be or HA to be calculating this. I can tell HA, I'm experienced enough, I can tell HA that how much CPU, 2 megahertz of CPU should be reserved. Okay, nobody from now on will be using 32 megahertz of CPU in all hypervisors. And 100 MB memory should be reserved. So suppose you as an administrator decide that. So you can actually put your own numbers here as well that please HA tell every hypervisor to that they won't be able to use this much CPU and this much RAM. We need to reserve it in case one of the hypervisor fails, right? I'll put it back to the HA analyze that. So that's what it's saying on the slot policy. If I go to the dedicated failover host, that is pretty simple and straightforward. You are reserving one full host as a backup host. Suppose I select this XI3 and I put it here. So this means what? That from now on, this host will do nothing but sit and wait for the disaster to happen. If suppose there were 10 hypervisors and one host has been dedicatedly put as a standby host, so if any one host out of the 9 running hosts from the total 10, if any one host um, is down, then this dedicated host will automatically become working host. So right now, it's just a dedicated failover host or standby host. So you can do it this way. One host just sits there and waits for the disaster to happen. Suppose the disaster does not happen for next 5 years, 3 years. So this host is just sitting there doing nothing. Or you can just use all the hosts and some part of that, some CPU and RAM from all the hosts is reserved, but all the hosts are working. Right? Or this one is also it's calculating cluster resources percentage wise. That was our policies exact megahertz and MBs you can put. This is percentage of CPU and memory. That's what you can decide here. Let HA calculate the percentage instead of actual amount in slot policy, right? So that's the difference. But overall, permission control is all about that um, we should prepare for disaster from today, right? Instead of react to a disaster. So it's already there in place and it gets enabled, and one host worth of services are reserved already. This means that you have less CPU and memory as soon as HA kicks in. You have comparatively less CPU and memory available in all hypervisors because one hypervisor worth of CPU and memory is reserved and you won't be able to use your virtual machines won't be able to use that, right? Okay. Performance degradation VMs tolerate. So percentage of performance degradation the VMs in the cluster are allowed to tolerate during a failure. So VMs could tolerate and keep on working even if 100% performance is down. Maybe the CPU is being used 95%, 98%. That's too slow for a virtual machine, right? No CPU is available. RAM is also on 95% or 98%, and no, not much RAM is available. So it just says, hey, virtual machine, just keep standing. Try to breathe a little, even if you don't have any oxygen. It's kind of that analogy there that try to tolerate this much and don't crash. Then there is heartbeat data stores. What is this? So heartbeat data stores is another interesting concept here that so heart heartbeat data stores. Uh, Here, um, heartbeats normally are sent from slave hosts or hypervisors to master host. But in case of in case of in case of host isolation, hosts are unable. Some hypervisors are not able to reach the master hypervisor, right? Host isolation. In case of host isolation, slave hosts can also send heartbeats to the data stores when they cannot reach master hypervisor. They can send that information to data stores. Hey, data stores, we're alive. We're alive. Can you send that information or forward that information to the HA in sitting in VCSA? So data stores can also uh, send that information. So I'll be explaining that in diagram. I can also send heartbeats to the data stores, and these data stores will inform the HA service that those slave hosts are okay and working fine. So in diagram, how does it look like? Now, there are many hosts here, right? No, sorry, data stores. So, like there are so many data stores here that are created, and those data stores are created on LANs, right? So, those suppose these are three data stores, but you have three more here. Suppose on top of LANs. So, suppose you have three more LANs here. These data stores are created on top of those LANs. So, what can happen is that suppose there's a host isolation. In fact, I'm going to go to the other diagram where it shows the host isolation of that's the host isolation diagram. So there's a switch, and we were talking about that the two switches do not have a communication for a certain time, and it's being troubleshooted by the administrators. So the slave hypervisors that were connected to this switch are now unable to go across to the other switch to reach their master hypervisor to send the heartbeat. So what happens is that some of the data stores are also given the responsibility that not only that the master hypervisor is going to receive heartbeats, but also the data stores will receive heartbeats and send it to the HA service of the cluster in VCSA as well. So data stores can also receive heartbeats. So suppose there was host isolation going on, and slaves are unable to communicate to the master that they're alive or not, or they're okay or not. So they can also send heartbeats to, if suppose some of the data stores are actually on this switch, but they are connected to some other switches, which are in turn connected to the either the master or the HA service in VCSA. So if the hosts slave host cannot send that information to the master host from here, they can still send that information through these data stores to HA service, or if the data stores are connected to any one of those HA service inside cluster inside VCSA or the master hypervisor. So this is another way to just send, hey, I'm alive, we are still okay. Yes, there's a We are isolated right now, but through data stores, we're sending you the message that we're okay and don't worry about us. So that's what's going on with the um, data stores being which are receiving the heartbeats. So that's why you can. It's a good thing to allow the heartbeat data stores to be there as well. So in that case, heartbeat data stores can also play an important role in informing uh, the VCSA about the about the well-being of the slave supervisors. Okay, so if we talk about some more, so that was HA related features. And I'm just going to select actually anyone. Actually, we can select all three. We can select or anyone we can select. It's up to you. But yeah, I'll go for randomly selecting a DS2. I'll select that and press O and K. Host mounting selected data store. So we don't have any host mounting selecting data stores, but these are the types that normally are there. I've clicked OK, but there was another option here, so I'll just go back here to edit. And heartbeat data stores, I've selected one, and then there's advanced option, as the name says. So this is something, advanced options are there. If you want to change the inbuilt features to something else, so there are these inbuilt features of admission control, heartbeat data stores. You want to disable one of the features, you have to get the code from the VMware support, and then you have to put that code here. That would change the nature of work of some of these features here. Also, suppose it also sends heartbeats to the router address just to check that are we in the same network or not. So you can also change the router address that okay, from now on our gateway address or router address or gateway address is different. We want to ping to another gateway address as well. So there are many ways need to get the code and you have to go to the knowledge articles of VMware to know that what kind of things you can make changes in. Normally we don't touch it if we don't really need it. Okay, so there's that vSphere HA features here. I'm just going to press OK here. If I go to proactive HA is turned on, so I'm going to go for proactive HA. Proactive, as the word says already, that you are going to decide even before the disaster strikes. You're going to make some decisions even before disaster strikes, right? How can you even possibly do that? So you can configure how proactive HA responds when a provider has notified its health degradation to vCenter, indicating a partial failure of the host. So normally what happens is that you have some kind of very good quality expensive monitoring solution, and that monitoring solution is giving you such an information. With the help of that information, you can predict this hypervisor is about to crash. Suppose there's a monitoring software and that is sending you alerts and event logs are also being sent to you. Those event logs might show that okay, 2 hours ago the CPU was on 80%. Last hour CPU was 92%, and in last half an hour CPU is gradually going up to 95%. It's kind of predictable that the way the CPU is being used gradually, and it still goes up and up and reaching towards 100%. So at 100% it's gonna simply crash, right? So this means that it can predict and do something about it that, okay, if gradually the CPU is increasing since last 1.5 hour, so I should simply we motion the virtual machines to another hypervisor and put this hypervisor either on quarantine mode or maintenance mode, right? Quarantine mode is just totally isolated mode. Maintenance mode is that you can't run any virtual machines on it. It's just available for maintenance only. So the thing is that if you have a very good monitoring software and um, you can connect that to vSphere, and then vSphere can actually make decisions proactively. Even before the disaster strikes, it could move the virtual machines away from that hypervisor. And hypervisor is on a partial failure state. In that case, it's going to do that. There's automation level, there's automated, and there's and there's manual state. Manual state, you decide yourself, or automated, it just simply does it. Starts moving virtual machines as soon as it gets some kind of events that proves that it's about to go down. Degradation of performance degradation is going bigger and bigger, growing and growing. Right? So otherwise, you can just decide yourself. And providers normally those are proactive HA providers could be the monitoring software. Suppose you've purchased a very expensive monitoring software and you um, um, integrated the monitoring software. Now, VMware has a very, very good but very expensive monitoring software called vRealize. vRealize is the name of the monitoring software that VMware offers. It's a pretty comprehensive software, and it does reactive monitoring as well as proactive monitoring. It's pretty expensive license based software, right? But if you have that integrated with your vSphere, then obviously it's gonna let you know and just even do something about as soon as the disaster strikes, way before that, actually. Yeah, this is proactive HA, and I'm going to cancel out from here. Then I'm going to go for DRS, which is also pretty cool service. In that DRS, we have, I'm going to go to edit of DRS, and it's pretty interesting. We do a lab on that as well. So automation level, DRS has automation, and automation level is fully automated. Then there's a migration threshold, and there is predictive DRS, and then there is virtual machine automation on this page. What is automation level and migration thresholds? This is where we can say that it's a very powerful feature. It keeps your virtual machine performance all the time up to 100%, provided that the hardware is available. How can it really achieve 100% or very good performance on virtual machines all the time and automatically? So how DRS really works is that so distributed resource scheduler. We already talked about when does it kick in, right? It uh, keeps analyzing the CPU and RAM availability every 5 minutes on all hypervisors. If there is a possibility of a better CPU and RAM availability, then DRS is on fully automated and full um, full and maximum terminologies here. And migration threshold is aggressive, and uh, aggressive migration threshold, and aggressive migration threshold. Then then DRS will move V motion automatically. The VMs uh, from uh, low performing hypervisor to high performing hypervisor. Right? So this is pretty cool service, and you could be like going somewhere else, trying to do some other task. If you put this DRS on a fully automated and fully aggressive migration threshold mode. So what does that all mean? It means that if your virtual machine here, this virtual machine here has like 90% CPU and RAM, CPU and RAM, consumed, and then there is here 60% CPU and RAM consumed. So it will see that, oh, there's 40% CPU and RAM more available here, and 10% CPU and RAM available here. So if you put it on fully automated and aggressive migration threshold mode for DRS, then DRS will simply start V-motioning the virtual machines from a low-performing hypervisor to a higher, comparatively higher performing hypervisor. Gonna keep on doing that. Suppose this hypervisor is on 60% and it went up to 70%, which is still good, which is still okay. But then you see another hypervisor, and that is still having 55% of CPU and RAM consumed only. So it will again move the first, it will move virtual machine from slower hypervisor to a higher performing hypervisor, and it sees that, oh, this offers even more CPU and RAM comparatively to this hypervisor. It's going to move from here to there. And we already know that vMotion can be performed on a virtual machine where end users are connected and they are working. You are actually moving the virtual machine from one hypervisor to another. So it is all possible. Users' experience will be that for a few seconds they won't be able to click, but then they start working even with better performance. So DRS keeps, if you put it on fully automated mode, aggressive mode, then it's going to keep on moving the virtual machine if it finds any hypervisor offering even better performance than the current hypervisor. It's going to keep on moving the virtual machine. So virtual machine is guaranteed to have the best performance, provided that any hypervisor is still available with better CPU and RAM. So it's going to keep on V-motioning the virtual machine. So this means that you as an administrator can do something else, resolve some other ticket, resolve some other issue, while you know that your users are, unless some disaster strikes, you know that your users are getting whatever best available CPU and RAM offering hypervisors there are. They're actually going to get that performance. So obviously, you have to keep an eye on the underlying hardware for that. That you still have during peak hours of 9 a.m. till 2 p.m. or 10 a.m. till 2 p.m. That time, you still have hypervisors that can still offer, acceptable amount of CPU and RAM. So DRS is pretty magical when it comes to that. So I'm just going to go back here, and it says here fully automated. So there are three He has three levels to that. So there's manual, and manual it says there's another terminology and there's another feature that we need to understand here. DRS generates both power on placement recommendations and migration recommendations for virtual machines. Okay, we have till now talked about migration, right? We understand it's gonna automatically be motion virtual machines if it sees better performing hypervisor. It's gonna be motion right away. Now, what is this power on placement recommendation or power on placement? What is power on placement? It kind of is some about what it's going to do in this wording, but power on placement is that when if your virtual machine is about to start or restart. So power on placement is that if your VM is about to start from a shutdown state or restart from a started state, then DRS will decide which hypervisor is the best suited for this VM in terms of CPU and RAM performance. That's called power on placement. So when your virtual machine is about to power on, then it decides. DRS does that too. Not only that, DRS vMotions an already powered on virtual machines from low performing hypervisor to a high performing hypervisor, but it also places, the word is places. It also places a virtual machine that is about to start now, either from a restart or a actual start from shutdown. So if a virtual machine is about to start, it can actually place it from a low performing hypervisor where it was in a started state to a higher performing hypervisor now that it's about to start again. So if the virtual machine was here and for some reason we have shut it down and we're about to start, or we restarted this virtual machine. So it's about to start either from a restart or from a shutdown state. So if it's doing that, so normally if DRS was not available, it's going to start to restart, it's going to start on the same hypervisor. But if DRS is enabled, DRS will already have the report that, okay, this hypervisor has 90% CPU and RAM available. This hypervisor has now 70%. Oh, this hypervisor has 55%. This hypervisor seems to be the best suited hypervisor. Since it's about to restart, let me just restart it on the RAM of this hypervisor. So it's going to actually place this virtual machine on this hypervisor. So it would start on this hypervisor and would be considered the best suited hypervisor in terms of availability of CPU and RAM. So that's called placement by the DRS. So that's called power on placement. So DRS does two things. What are those two things? One is vMotion. Second is placement. So, and both types of things guarantees better performance. DRS is pretty expensive and it comes with the expensive licenses. So obviously you will see DRS being used in very large environments, right? Because it's available with enterprise licenses. But obviously this is where you have thousands and thousands of virtual machines and you really need a lot of automation. So you could do something else as well. If we go back there, it says power on placement. So if you put it on manual, it will only do recommendations of placement. it will only do recommendations of vMotion. When you put it to manual, when you put it to partially automated, it's going to actually start automatic placement of virtual machines on the best suited hypervisor. But it's going to still do vMotion or migration recommendations only. If you put it on fully automated, then obviously it's going to do both things automatically. It's going to do placements automatically. It's going to do migrations automatically. Okay? So suppose we put it on fully automated. Then there is that migration threshold. Oh, when do you want the virtual machine to be vMotioned to another hypervisor? There are stages here. The first stage it just says it, and they did not actually gave any fixed numbers there. It's their internal algorithms on the basis of which they decide that when the virtual machine needs to be migrated. So they say that frequent vMotions, and when you put it on fully aggressive mode, what happens? DRS provides recommendations when workloads are even slightly imbalanced. That's the extreme state. That's a high state where virtual machines might be vMotioned maybe within 1 hour to these 8 or 10 hypervisors. It's so aggressive and it's gonna so frequently vMotion the virtual machine because it would DRS might keep on finding better and better hypervisors with more and more CPU and RAM available, right? So if you put on aggressive mode, if the DRS sees even slight improvement, we can translate it into like, oh, this hypervisor has 70% CPU and RAM, but this hypervisor actually has 70% consumed CPU and RAM, but this hypervisor has only 65% CPU and RAM consumed. Oh, that's a 5% difference. That's a slight difference, but it's a difference. And this hypervisor is offering more CPU and RAM, 5% better CPU and RAM. So it's going to move virtual machine to this one. So that is called slight improvement, slight imbalance. Now I put it at 5% difference. What VMware takes it, maybe it could be 10% difference, maybe it could be 7% difference. We have to dig out in their documentation what exact numbers are there that the DRS would decide in this setting, fully automated and fully aggressive, that it's going to decide that, oh, now I'm going to move the virtual machine, but it's slightly imbalanced, and then it's going to move virtual machine. So if I go to the fourth level, then it says fairly imbalanced, right? So that could be a bit higher number. We could give careful guess here. So it's 70% and it's like maybe 60% difference or 55% difference. If there's a 55% difference, then it's gonna move. I'm just giving you kind of an example, but it's not the exact number. Then moderately imbalanced, if you put it on middle, and if there's a moderate imbalance, then it could be obviously a bigger difference. This is 70. Maybe if it's offering 50% CPU capacity consumed only and 50% available, while here 30% available and 70% consumed. That's a moderate difference, right? Then it's going to move, otherwise it's not going to move. Okay? And then it goes down to extremely imbalanced. That's a big difference, right? So 70, maybe there is only 35% consumed CPU and RAM, which is pretty much it's empty. And here 70% consumed CPU and RAM. So that's offering a lot of CPU and RAM here, right? So if it is a big difference, only then it's going to move vMotion or virtual machine. Or if you go down to constraints, if the current hypervisor has to be moved to maintenance mode only, yeah, like it's going down anyway, only then it's gonna move vMotion the virtual machine. Otherwise, it's not gonna motion the virtual machine. Even no matter how bad the performance is, when it's going to maintenance mode where virtual machine cannot even work, right? Then it's going to move. So that's the difference. And VMware by default has put it to the uh, middle of it. But what we're going to do to test this is we're going to do a lab now, right? We're going to test this feature. So I'm going to keep it to fully automated. I'm going to put this one to fully aggressive. Right? So why am I doing that? Because we need to test it. Guess what? How? We're going to test by putting the pressure on any one hypervisor. We're going to start all the virtual machines in any one hypervisors. If they are not all on one hypervisor, we're going to move them to one hypervisor. And then we're going to leave them on that one hypervisor and check that does DRS balances that, does DRS moves vMotion some of the virtual machines to the other hypervisor itself automatically. What we're going to do, we're going to make sure that all virtual machines just are gathered on one hypervisor and we're going to power them on. This means it's going to consume a lot of CPU and RAM for that hypervisor. Then we will leave it to DRS. Hey DRS, you want to move it back? Go ahead. So that's what we intend to do. We're going to put it on fully aggressive and fully automated. I'm just going to press O and K. But there is one more thing, guys. What I don't want right now is the admission control. Wasn't the admission control a very critical thing? Yes. Okay, what do you not want in admission control? You'd be thinking. So, what I don't want in admission control to be enabled, I'm going to go there. I'm going to show you now. I'm going to go to the admission control. I'm going to disable it. Disable what? Disable the whole admission control. Why? Because right now it is doing a capacity reservation of one hypervisor worth of virtual machines. So this means that right now one hypervisor worth of resources are not available and we are not allowed to use them in our environment as well. We already have very less hardware. It's a training environment. We don't care about admission control, at least in our training environment, but we do very, very much care about admission control. The production environment in companies, yes, it's good. Here, it's no good because it's eating up the limited resources we have, half of the limited resources that we have. So I have to disable admission control. What I'm asking here is, hey, I want to use the full RAM and CPU of my two hypervisors. The poor two hypervisors that I have won't restrict me to use half of the CPU and RAM capacity of the two hypervisors, right? This is a must if you want to do future labs. This is a must. So I'm going to go back and press O and K to make sure that admission control is disabled. Right. So, is it? I'm going to just go back and check. How I'm going to check vSphere availability. I'm just going to click edit again. It's disabled. Good. Now I'm going to go back to DRS. I'm going to go back to edit, although I have put it to full aggressive and fully automated. So this is what I want. Why? Because now I will put all the machines, try to put as many virtual machines on one hypervisor and then power them on. Right? So for that, I need to know which virtual machine is in which hypervisor. Okay, VM01 and the summary view. Virtual machine in the summary view. This virtual machine is on E6i3. Okay, this virtual machine is on E6i2. This is on E6i2. This is on E6i2 as well. Oh, majority are on E6i2. Again, E6i2. So last machine, E6i2. ESXi2, ESXi2, ESXi2. If those who are following, if yours is different, just make sure that all virtual machines are on one hypervisor. I'm going to power them all on, and you will see the magic of DRS. So I want to make sure.
Yes, but only the VM01 and EXSI3, right? Okay.
Like either gather on ESXi2 all machines or on ESXi3 all machines. Yeah, same thing. Okay, ESXi2.
EXSI, I mean VM01 is on EXSI.
Yeah, 3. So I'm gonna move while it is shut down. I'm gonna move it to ESXi2 as well. So my all machines, I want to make sure are on ESXi2. Then I'm gonna power on all the machines. DRS will check. Oh, CPU and RAM is fully used, and the other ones CPU and RAM is not used, so it's gonna automatically place and move all the virtual machines to ESXi3. That's what we want to see. Okay. So VM01 is on ESXi3. I'm going to move this while it is shut down. I don't want to power on right now because DRS will detect that. So I'm going to move this guy, migrate this guy to A6i2 as well. Okay. Okay. It is on SSI3, but oh yeah, this is that troublemaker. If I go to edit settings, it's not giving me the destination. Why? Because of the CD DVD has mapped ISO. Maybe I removed it, but stubbornly thinking that, oh, I don't even have a CD DVD because I think I removed it and it still thinks, no, you did not remove it. It's still there somewhere. I am not going to let you move. Okay, some machines are stubborn. Guys, I really don't want this machine anymore because it cannot migrate. I'm just gonna get it out of our way. I'm gonna delete this machine from this. Yes. Why? Because it doesn't even migrate and it's stubbornly sticking to no, you have that CD DVD there. Side 2, side second machine, side 2, third machine, side 2, fourth machine, side 2, fifth machine, okay. All are side 2. DRS is in full swing, full automation. So what magic are we expecting? We are expecting as soon as we power on all the virtual machines, leave it, what we're expecting is some of the virtual machines will be automatically placed on E6i3. But I'm only going to power them on. I'm not going to migrate them. I want DRS to place them on E6i3 or migrate them to E6i3. If they were already powered on, it would have migrated. But right now, as I start, it's gonna do the placement thing. So I'm starting all virtual machines on 2. I made sure that a couple of times. I'm gonna power on and leave them and see the magic of DRS. Right click, power on, right click, power on, power on, power on, third machine, power on, fourth machine, power on, fifth machine, power on. Now it's consuming a lot of CPU and RAM, and the other one has more CPU and RAM, so we're gonna leave it at this and check back. It's gonna immediately do that actually, but by now it would have actually done the placement. Some of the machines, while starting, might already have been moved to E6i3, but migrate. I never migrated. I just powered on. There's a migrate going on. Hey, who's doing that? Okay, so yeah, it's DRS. So live migration going on, but while I did not start that. So DRS is doing this. Now if I check, the first machine is still on 2. Second machine, which I did not migrate, on 2 or 3. Oh, it's on 3. Okay, that's placement, right? Is it on 2 or 3? We're all on 2. Now, oh yeah, it is also on 3. I only powered on. Is this on 2 or 3? It's also on 3. And the last one. It's still on 2. So it balanced. DRS balanced that 3 of the virtual machines it placed on other hypervisor. I did not go through the migration process. It just placed it itself, which is pretty cool stuff. DRS really works magically. So, but someplace here, DRS activity should be logged as well, right? What about if somebody wants to ask for a proof? Hey, okay, this happened, but is there some auditing going on? Was it put in the auditing? Okay. So if I go to monitor here, oh, okay, I'm going to go to Tor cluster, and then I'm going to go to monitor. And if I go to history of DRS related monitoring and then HL related monitoring, right? If I go for history of DRS related monitoring of cluster, now you can see that one machine was migrated. I didn't do any migration, I didn't do any placement. DRS did all that, and the time is there as well, right? So place this machine there. So place this on 2. I did start that. It calculated everything, and it says that okay, keep this on 2. This one was also on 2, VM03, but it said no, place it on 3. This was on 2. It says no, keep it on 2. And this one, place it on 3, keep it on 2, and keep it on. It was on 2, but it migrated to 3 as well. So this is pretty amazing, and there's the proof here as well that DRS really works, and it works like a wonder. I'm gonna power off all the machines because I still need a lot of CPU and RAM. I don't want to split it on this. Okay. Uh, gonna turn them off. Okay, if anyone needs a break, this is the time. Otherwise, I continue to. Now, all the machines are off, and so DRS works like wonder, but what are the other features of DRS? If I go to Tor cluster and go to configure, and I'm on DRS, and then I go for edit. So when I click edit, okay, so we get that automation level and monitoring threshold are amazing features. Now, it's not compulsory for you as an administrator to put it on fully aggressive mode, but like if you want to do that, yes, the automation is there available for you. Predictive DRS, enable predictive DRS, and that would just simply, in addition to real-time metrics, DRS will respond to forecasted metrics provided by, I told you that software called monitoring, expensive enterprise grade monitoring application developed by VMware called vRealize. So if you have that monitoring application purchased and you integrate then to the vSphere VCSA, then it can actually give you a forecast. So only forecasted metrics with high confidence will be considered by DRS to balance the cluster's workloads prior to predicted utilization spikes and resource contention. So it can predict, vRealize monitoring software can predict that this hypervisor is about to have degradation of performance. And while as soon as it predicts, it says that only the high confidence ones where the it's highly confident. We realize, and DRS is highly confident that yes, this is a solid information, and on the basis of that information, it's going to just migrate or vMotion the virtual machine away from that hypervisor, which is about to have degraded performance. That's pretty cool. You want to enable that. This is also a good option to enable. Virtual machine automation, enable virtual machine automation, and that says override for individual virtual machines can be set from the VM override space. So what is override? Override is that you want a virtual machine or set of virtual machines not to follow DRS rules and not to follow availability rules. You can override also a virtual machine. So suppose I press OK here and go down. So there's a VM override. You go to VM override and then go to add. Suppose we go inside, then all the virtual machines are here. Obviously, we don't touch the VCLS because they're running the cluster. But all the other virtual machines, you can suppose this is a virtual machine. You select that, hey, this virtual machine should not be following any HA rule, availability rule, or DRS rules. So you can select the machine, you can go next, and then you can override that. Okay, DRS, I don't want. Level. Oh, HA, I don't want. Restart priority, don't restart, don't touch this machine, and keep going for any of the options that are applicable to all virtual machines from DRS and HA. You can go through one or two virtual machines, one by one virtual machine. You can change those options of DRS and HA, which policies of DRS and HA should be implemented on which machines and not on certain machines. So it's up to you what you want to do. Yeah, this is how you can override on a machine level. Suppose certain machines you don't want DRS and HA policies implement. Cool feature. If I go back to DRS and add it, so we see that there's virtual machine automation, which is pretty much which is actually override feature, and there is additional options here. It says VM distribution. That's also pretty interesting option. So suppose you have so suppose DRS sees that, oh, this hypervisor has 45% free CPU and RAM. Okay, I have here 10, suppose 10 virtual machines the hypervisor has, 10 VMs, right? And suppose it actually moves 7 VMs here. Oh, 7 VMs here. Oh, it has so much CPU and RAM. And 3 VMs here because it has less CPU and RAM. Okay, that's what DRS is supposed to do, to give better performance, right? But what if this happens? This hypervisor crashes. Majority of the virtual machines definitely will be affected. They will be restarted. Users will be effectively disconnected, which means there's a downtime. Your business loss has occurred to a certain level, right? So you would not want a lot of virtual machines to be moved to any one hypervisor. If that hypervisor restarts, you have 7 or majority of the virtual machines are restarting. So there is that option available that says enforce a more even distribution of virtual machines across hosts in the cluster for availability purpose, right? May see a degradation of DRS when utilizing this setting. If you enable this setting, then what will happen that it's going to evenly distribute the setting. Oh, okay, let me but there are 10 virtual machines here. So let me put 5 virtual machines here and 5 virtual machines here. So if one goes down, obviously, majority of the virtual machines were not restarted. Just half of them were affected. But the downside to that is you kept on a slower hypervisor, more virtual machines. This means the virtual machines here will still have degraded performance. You try to go for availability instead of performance, right? So there's that fine line. What do you want to select, availability or performance? So up to you. But there's that option that VMware says that you should know. It's available. You want to use it, go ahead, use it. CPU overcommitment. Overcommitment is just that you want certain machines to have more CPU, even more CPU allotted to them than what is actually available physically, right? So maybe physically there is 16 cores CPUs available, but you have virtual machines allotted, 4 core here, 8 core here, 7 core on another very, very critical virtual machine. So that you don't have that many cores of CPU available physically. You are trying to allot that. So that is possible if you enable that, but you have to be just very careful. One vCPU ratio with one physical CPU, right? So it's 1 to 2, 1 to 1, or 3 to 1, three vCPUs in ratio of one physical CPU. So you can actually do that too. If some non-critical virtual machines, you don't want that CPU to be given to that, and all vCPU should be given to the most critical machines. And then scalable shares, enable scalable shares for the resource pools on this cluster. So it still says that, shares, what was shares? Shares means priority. So scalable shares means that increase the priority of certain critical virtual machines. If those machines have been deemed critical, then yes, increase their priority, as well as, if they are getting busy and there's a tug of war of every virtual machine is looking for CPU and RAM. So priority wise, distribute virtual CPU and RAM to the virtual machines according to their criticality. So there are these extra options there that you can choose, and it's good to know that they're there. Other than that, there is DPM. What is that? Distributed Power Management. So DPM is very interesting as well. Distributed Power Management. It ensures controlled hydro costs. Well, how? It checks which, at nights slash weekends, if, uh, at nights and weekends, uh, it checks at nights and weekends how many hypervisors are being used. It analyzes, it runs an analysis of that, the utilization of hypervisors, and then uh, moves VMs to fewer hypervisors, and then shuts down automatically some hypervisors. So to save electricity costs. In the morning, it then remote starts the shutdown hosts once the users start connecting VMs. right? So that's a pretty good automated system. For big companies, this would be a big blessing. Like if those companies want to, uh, they have a lot of hypervisors there, and they do want to save some electricity costs, hydro bills as well, right? So in that case, what happens is DPM, if it is put to automated mode, then it checks that, oh, how many virtual machines are there suppose there are 10 virtual machines there, 20 virtual machines here, 15 virtual machines here, 30 virtual machines here. But it sees that on nights and weekends, since there are no end users connected here, so the utilization of CPU and RAM is very, very less. And it analyzes that if I move, virtual machines of some of the hypervisors to the other hypervisors, because none of them are being used and they all have CPU and memory available. So if I move, suppose out of five, the virtual machines or two hypervisors to the rest of the hypervisors, still, there will be enough CPU and RAM available because nothing is being used. So once they are moved away, then DPM inside DRS will do a remote shutdown command, and those suppose there are 1,000 hypervisors, right? And on weekends, DPM does analysis and then moves virtual machines from 50 or 100 hypervisors out of 1,000. That's a lot. Right? And then it shuts down remotely, moves virtual machines from 100 hypervisors, shuts them down, and you're saving every night the electricity costs of 100 hypervisors. So because of DPM, right? But and on in the morning when the end users, suppose on Monday morning, all the end users can start connecting, and then DPM realizes that, oh, okay, now more hypervisors are needed, so it sends a remote start command to those hypervisors, and then this when they start, it starts moving all the virtual machines back to those hypervisors. Only catch here is that it is possible it sends a remote start command and the hypervisor does not start. Then you have to make a run for it and check that what component failed, what physical component of the hypervisor failed that it did not start. If multiple hypervisor do not start, all of a sudden you get to know that, and then you make a run for it, try to fix the issues and get the hypervisors up and running. So you might want to do that uh, to newer physical servers and not to the older physical servers, and you have to then check that remote start or wake on LAN really works or not. So DPM is a pretty good feature for saving electricity. Now, if we go ahead, there are advanced options, and obviously, if you want to change the nature of any of those options here, then you contact the VMware support, get the code, add it here, and that many things, whatever you want to change gets changed then. But you have to do some good documentation on that. You have to read a lot of documentation on that. Hence the name, advanced options, right? Okay, there is another feature called affinity rules, which is also very, very important. It says affinity rules, but they are configured here in VM host groups and VM host rules. And what affinity rules means is affinity rules. Um, so affinity rules are that um, a VM to VM affinity. There is a VM to VM affinity, VM to VM anti affinity, VM to host affinity, VM to host anti affinity. right? And then there's a fifth one as well, and that is VM start order according to dependency. Okay, so VM to VM affinity means that these slash any two VMs must stay together if vMotion needed, right? So there are scenarios where you need to, the DRS might move one virtual machine to another hypervisor, but there are certain types of applications on those VMs. Maybe similar type of applications are on two VMs, and those VMs performance will be affected. Application performance will be affected if any one of the VMs was moved away from the other on another host. So you can create a VM to VM affinity of two VMs, if you think that these two VMs must stay together, whichever host they are vMotioned to, moved to, right? And that's the opposite of that. Uh, uh, these two VMs cannot be on the same host together. Now, this is a typical scenario where IE FT or fault tolerance, where there is active, passive VMs are there. So first of all, VM to VM affinity, if I go there, well, that's messed up. So VM to VM affinity would be pretty easy. That VM to VM affinity, that if there are two VMs in one host, and those two VMs have pretty much the same application. So whenever DRS decides, oh, this hypervisor is performing really good, and I am choosing this VM to be moved there. But then it sees the VM affinity rule applied to these two VMs, and either it will then analyze again that if I move two VMs at the same time to the same host, will they be getting better performance on this target host, which is better than the current host, right? So then it will decide, but it has to, then DRS has to follow the affinity rule. VM to VM affinity means both machines move or none of those move, right? So that's VM to VM affinity. And VM to VM anti-affinity would be obviously that the virtual machines, one virtual machine is here, and the other virtual machine is here. But this virtual machine is actually the active virtual machine, and this VM is the passive VM. So passive or standby VM. So now, obviously, they are interconnected. There's synchronization going on. Whatever is changes are happening here are being written here as well. So suppose the DRS decides that, okay, see that this virtual machine is having underlying CPU and memory, and I see that this hypervisor can provide more CPU and memory. So I am deciding, DRS says that DRS is deciding to move this virtual machine to this. But then it sees that this virtual machine have has this rule implemented on them. These two virtual machines have this rule implemented, anti-infinity. So it sees that, oh, although this hypervisor offers better RAM, but I cannot move it to this hypervisor because the other partner virtual machine of this virtual machine is actually here. So obviously in big environments, they will have more hypervisors there. And those hypervisors, if any one of those hypervisors also are offering better RAM than the current host, it will still move. DRS will still move, but it will not move it to this hypervisor, but it can move to any other hypervisor. Right? So it will intelligently decide that. Obviously, it will see the policy and it then cannot move them on both to one hypervisor. That would fail the purpose of fault tolerance. Why? Because if active and passive are on the same hypervisor and it goes down, then what's the purpose of putting it as active and standby VM, right? They have to be on separate hardware. If one fails, other becomes ACK and dev. So then there is VM to host affinity. A VM cannot, particular VM cannot leave a particular host. I.e., if a VM requires a specific hardware that is provided by a specific host. So that could be an example, and other hosts do not provide that, right? And other hosts do not provide it. So if this virtual machine is moved away from that host, that virtual machine's critical application might stop working or it could face very bad performance, which could in turn be a loss to that company, business loss for that company. So that would be a VM to VM anti-affinity, where VM is restricted to one host. VM to VM to host. Sorry, VM to host affinity and anti-affinity. So that would be if a virtual machine is supposed to be on one host and that host has uh, more specific hardware that is required. For example, this host offers 1 TB RAM, while other hosts offer 32 GB RAM, right? So in that case, and then that application requires a lot of RAM. So this means that if DRS moves this machine away from 1 TB RAM host to a 32 GB RAM host, this application might not work. It will have very bad performance and business will have a loss. So you cannot move. So if a DRS is about to move this app and it's a virtual machine and it sees that, oh, there's a VM to host affinity. Okay, get it. I'm not going to move this virtual machine away from this host. And the anti-affinity is that a certain virtual machine cannot be on a certain host. So anti-affinity would be obviously the opposite of that. That okay, DRS, you can move this virtual machine to any other host, but that host or that set of hosts. So suppose those hosts have 32 GB RAM, while all the other hosts have actually 1 TB, suppose 1 TB RAM. So you are saying that anti-affinity, that this virtual machine cannot be on host 2 and 3, but you can still move it to, hey DRS, you can still move it to the rest of the hosts because they all have 1 terabyte RAM, right? That would be the anti-affinity. VM2 host affinity and anti-affinity, and VM start ordering. It's just that opposite of VM cannot be on certain hosts. And this is just, we can set start order of VMs. These are the affinity rules, and we understand what they are, but how they are configured, where are they configured? Let's go ahead and do that. Now, they are called affinity rules, but theory, but in practice, uh, uh, in practice, in practice. So in practice, they're called VM host rules and VM host groups. Now, we don't have a lot of hosts here, but I'm going to show you that how they're configured. So we can create groups. Although if you just want to deal with individual machines like VM to VM affinity, VM to VM anti-affinity, then you don't need to create groups. But obviously, wherever there are hosts involved, then you need to create groups. So suppose I go for add host just to show how does it look like. So there's VM group, there's a host group. Suppose you have sales department VM, sales DEPT dash VMs, right? And you create a VM group, but obviously you have to add some virtual machines pretending that, okay, suppose we pretend that these two are sales department VMs, and I press ONK. It could be, based on grouping, could be based on anything. Maybe they are high performing virtual machines, maybe they are all databases, maybe they're all file servers. So whatever is the basis of grouping them together. You can create a group for host as well. Suppose I go for host group. So suppose for branch host. Suppose we have like 20, 30 hosts there, and I click add. So it's going to show all the hosts. I'm going to add only one host here. And just to show that, okay, this is how it looks like, and that's how hosts can be added. Okay. If we go to VM host rules, there's that. We're going to add here as well. Now you can see that keep virtual machines together is the VM to VM affinity rule. And if we go down, separate virtual machines, that's VM to VM anti-affinity, and virtual machines to host affinity and anti-affinity, both can be configured here. And then virtual machines to virtual machines, that is the virtual machine group you want to start first, and which group you want to start second. Now, if we go for the first one, and we can name it however we want, VM to VM, VM dash to dash VM affinity. Suppose we put that and select this first one. We can click, and now this means that whatever number of virtual, suppose last two virtual machines randomly I'm selecting, these two virtual machines must stay together. Well, that's how you would configure it. Okay? Stay together. And if I press OK, yeah, DRS will know now that, oh, okay, these two particular virtual machines have this host rule. Okay. If I click add here, this time I select the second one, separate virtual machines. And then whatever you want to name it, VM to VM anti-affinity. Now when you add suppose I go for one VM from this group and one VM from this group. Now these two cannot be together on one host for any particular reason. I'm just randomly selecting, in fact, but ideally we would be selecting those two machines which we use for fault tolerance or as active and standby virtual machines, right? So suppose you want to select that, so that's how you would select the two machines or three. It's not only two. Suppose I go for four, so it can add. I'm going to remove those extra ones, but it's not like only two machines are there. All those machines you put here, suppose you put here 20 machines, so all those 20 machines cannot be on the same host. And DRS has to be careful that they all, suppose you have 1000 hosts, 20 machines cannot be together on one host. Right? So that's how the situation could be. I'm going to press OK. Well, that's what it's going to look like. I'm just going to click add again. This time, if we go for virtual machines to hosts, that's where VM to host affinity and anti-affinity will be configured. But how? So you can see that now it uses groups. Remember that we created groups before? So it shows the groups there. Sales department VMs. So suppose we had multiple groups here, marketing department VMs, IT department VMs, suppose in a big company. Sales department VMs must run on hosts in group, this many hosts. So then this is what you can select. Must run on host in a group, should run on host in a group, and then must not run on host in a group, and should not run on host in group. So what are these? Must run on hosts in group is a must. So this means that this group of virtual machines must only run on this group of hosts. Suppose there were 20 hosts here, hypervisors. If we go for should, so this means that these it's highly preferred that these virtual machines should run on these hosts, but for some reason you could not run these particular virtual machines on these particular hosts, then you can run it, you can move it DRS to any other hosts. But first preference is that move these virtual machines whenever you want to move these hosts. Not possible, okay, then you can go ahead and move to some other host. Suppose they don't have CPU and RAM and is not fulfilling the criteria of DRS. So would this option would let DRS decide other hosts. Must will be that DRS must move here. If enough CPU and RAM is not available, don't move. That's what it would mean. And must not would be the same. These VMs must not be run on these particular hosts. Okay. Or should try your best not to run those VMs on this host, but if in case you have to move the VMs and there are no other hosts available, then last preference is go for these hosts and move them there. And then so I'm going to go to the final option here which is virtual machines to virtual machines, and that's where you should have then multiple groups of virtual machines. VM dependency restart condition must be met before continuing to this group. So on restart for VM group. So first suppose we create two groups of virtual machines. So first this will start and then whatever it is depending on the start. So it's up to you how you want to order the group of virtual machines to start. So guys, yeah.
On my side, I'm having the second, a value in the second field. Yes, if you select virtual machine to host. Yes. Here in the host group, have it's empty. Have it empty.
You didn't create the host group then. Okay, if you go here to groups, if I go to groups, then click add. So you have to change that host group.
Okay. Thank you.
Oh. and then yeah, set the host. So guys, yeah, we haven't taken screenshots here, so um, we can take one screenshot here. I'm gonna click this VM host rules where VM host rules are showing, and we can call it affinity rules. There's take a screenshot here, and label is affinity rules. I'm gonna go back to DRS settings, and I'm gonna take a screenshot there as well. So this is affinity rules screenshot number one. Label affinity rules. Affinity rules. Okay. Screenshot one, affinity rules. Second thing is we're gonna go for the DRS settings. I'm just gonna go back here for the next screenshot, and that is I'm gonna go to the cluster level where I'm already. I'm gonna go up here on the configure and vSphere DRS. I'm gonna go there, vSphere DRS. So this is the DRS main configuration. So we can just say DRS configuration as label 2. I take a screenshot here where we see the configuration of DRS, and we can call it DRS configuration. For the second screenshot, DRS configuration. DRS configuration. Okay, so uh, if I go back here, go to availability. Okay, HA configuration. That's the third screenshot now. Click the availability here, and then the third screenshot is HA configuration. Third screenshot is HA configuration. Third screenshot. HA configuration. HA configuration. Okay. If we further move ahead, guys, few things we need to do. I've showed you how to configure that affinity rules, but these affinity rules will actually bug us in future labs. So how to configure them, how do they look like is what I've shown you, but we don't want them here. So what I'm going to do is I'm going to remove the VM host rules because we need those VMs for fault tolerance as well. So I'm going to just go to the VM host rules. The first one is already selected. I'm going to click delete for the first, and I'm going to click the delete for the second one here as well. So delete, okay. On second one, delete, okay. If I go to VM host groups, that's the same thing, delete, okay. And the second one is hosts, delete, okay. Right, so there's one more thing here, and that is VMware EVC. enhanced vMotion compatibility. If I go to VMware EVC, what is enhanced vMotion compatibility? So EVC is going to fool the vMotion into thinking that the source and destination hypervisor processors have exactly the same features. So go ahead and vMotion the virtual machine. I'm gonna explain that in English as well. So it's EVC, enhanced vMotion compatibility. And what that does is it fools the vMotion feature into thinking that the source and destination hypervisors processor um, processors are fully compatible with each other. So go ahead and migrate the virtual machines. In other words, EVC hides the incompatibilities of the source and destination hypervisors from the vMotion service. As long as the processors of the two hypervisors belong to the same generation family of processors. We kind of discussed that before as well. So they must belong to the same generation. That's all is needed. Then emotion happens. So, how does it look like? Let's go there and check it out. If we go to EVC here, now one more thing that it is very critical, is critical about it. A very important feature called FT or fault tolerance requires that EVC be enabled on all participating hypervisors, right? What does that mean? Whichever hypervisors are taking part in the fault tolerance configuration must have EVC enabled. If EVC is not enabled, fault tolerance will not work. Okay. If EVC is not enabled on a hypervisor, then FT will not work on it, which is not a very good news then. So if I go back here, there's an EVC here, and there's that disabled in here. How does EVC looks like from inside? I'm going to click Edit. So now you can see that it says enable EVC for AMD hosts, AMD processors based hosts, or EVC for Intel processors based hosts. And it's gonna tell you which generation your hardware processor belongs to, whether it's from Intel or AMD, right? If I go for AMD, obviously, just want to show you there my processor, my machine processor is not AMD, it's Intel, but how does it look like? So CPU mode AMD Opteron Generation 1, Generation 2, Generation 3, Generation 4, no 3D now, and then without that. And here's Pile Driver Generation, Steamroller generation, then AMD Zen generation, Zen 2 generation. So these are the names of the generations, but obviously these are processors from AMD company released at different times and having different architectures and features, right? So um, does your current hardware processor belongs to any one of those generations? So if I select any of those generations, it's going to check your current underlying, your hardware, laptop or desktop hardware processor, and it's going to tell you whether it is compatible or not. Obviously, mine is Intel, so error will be here. I'm going to move to Intel now, see how does it look like from inside. So Intel VROM generation, Range generation, NLM, Westmere, Sandy Bridge, Ivy Bridge, Haswell, Broadwell, Skylake, Cascade Lake. So these are the names of the Intel processor generations. So if I go to MIROM, which is the first one, and go down, addition succeeded. And if I go to actually anyone randomly now, forward addition succeeded. So yeah, my hardware, our hardware is not VMware compatible servers like Dell servers or HP servers. VMware has a HCL. What is HCL? Hardware compatibility list. HCL. HCL is list of that hardware that VMware tested uh, for their own software. Now, ours are laptops and desktops. I mean, these are not used in production environments, right? So either it might tell or it might show your processor belonging to any one of the generations, or it might show none of those generations support that, or it might show that every generation, this processor belongs to every generation. So if I go to randomly third one, it's showing that it belongs to that too. That's not true. I mean, it will belong to any one generation. It was a server grade processor like HP server or Dell server or IBM server. It would have shown it belonging to any one generation here, right? But this is just a test environment, tested virtualization. So it's just compatible with any one of those processors. But if this compatibility is there, only then the next lab FT could be done. FT is one lab that totally belongs on the belongs on this EVC being enabled. If EVC is disabled, which means that your processor does not belong to any one of those generations, then FT is something that's not going to be possible on your hardware. So, VMware has its own uh, standards, but obviously you have to know that when you're seeing it, because then you can tell this whole information in the interview as well. Right? So knowledge is always power, and in the interviews they check your knowledge, right? How deep you know, what kind of things you know that relate to their environment. The more knowledge you have, the better your interview would be. So if I press OK here after, so now what we did for last few batches, few of the users processors were showing not compatible, so we had to go for a workaround, and that was we would go to the um, hypervisors. Suppose it's not showing, it's showing not compatible, right, for any of the Intel generations. You go to the settings of the hypervisor 2 and 3 because they're going to take part the FT, and then go to processor. So the workaround for that one was that we just enabled either performance or we enabled this IO third option. After shutting down, enable this option and then start IOMMU. And then we would go to EVC, and EVC would just detect that for many of the laptops, previously created laptops, I mean older laptops. So that would be the workaround if in case EVC does not detect yours. Now, this is EVC, this is anti-finity rules. Then comes another bigger lab actually, that is FT. So instead of FT, I can start showing you another lab that is doable for till 9:30. Because FT is a bit bigger lab, or I could just pull off that FT as well. Check it out. So fault tolerance. Let me just quickly grab the basic features of fault tolerance from a random. So yeah, fault tolerance. Fault tolerance is that how vSphere fault tolerance works with vSphere HA and vSphere DRS. As I mentioned before, the fault tolerance kicks in when suppose there's a one virtual machine. This is a hypervisor, this is a hypervisor, this is a hypervisor, right? There are virtual machines on top of that. So fault tolerance works in a way that the hypervisor is down or a virtual machine is down. So first of all, you're going to create a FT for a primary virtual machine. So suppose this virtual machine is critical virtual machine. So what you do is you can only configure FT for those virtual machines that which are critical. You can't just create configure fault tolerance for every virtual machine. Technically, yes, you can configure fault tolerance for every virtual machine, but that's gonna take a lot of bandwidth. So it's not recommended to configure fault tolerance for every virtual machine. Second thing is that uh, once the virtual machine has so here it is not called active passive. The active machine is called primary machine. Passive or secondary virtual machine is well, standby virtual machine is called secondary virtual machine. Now what happens is if the active or primary virtual machine crashes, the secondary becomes the new primary, right? That's the first thing. Second thing is that secondary virtual machine will not wait for the primary virtual machine to come back. It's going to create its own new secondary virtual machine as well to become redundant, to have the high availability configured right away. That's a very good thing. So for that, minimum three hypervisors need to be there. Big environments, obviously, this works fine. But fault tolerance can be configured for only critical virtual machines. That's the first thing. Second thing is if the virtual machine goes down or the hypervisor goes down, the secondary becomes the primary, but it creates, if there's another hypervisor available, then secondary automatically creates a copy on the other hypervisor. So that's one thing to know. And the other thing is that yes, the primary and secondary virtual machines need to be on their own desk stores and own separate physical servers, and that it creates two configuration files and two disks separately. So secondary virtual machines own configuration file .vmx is created, and secondary virtual machines virtual machine disk file is separately created. I'm going for some important points there. Uh, when the primary and secondary virtual machines are created, so whatever is happening in the primary virtual machine gets copied to the secondary virtual machine. Obviously, this is synchronous replication, and synchronous replication is that what same time replication. So whatever changes are happening in the VMA, the same changes are being written at the same time. They're being copied and written to the secondary machine as well. So that's overall what fault tolerance really is, and the configuration file has a checkpoint, and from that checkpoint, all the changes are being, or deltas, as we can say, copied to the secondary virtual machine, which is an exact copy of the primary virtual machine. And the VM guest OS, so there's a unique universal ID, universal unique ID, UUID, that is unique to each virtual machine. And that information is stored in share.bmft file. And basically, fault tolerance is configured this way. But now I'm going to show you some of the fault tolerance FD or fault tolerance. See details in separate slide. But what I want to show is the lab for fault and Lorentz. What would say? So I wanted to just check and show the lab and lab configurations. Okay. Now, these are some of the configurations that we have to do. The prereqs, we can say, to fault tolerance, but overall what fault tolerance does is you create an active machine here, you create a passive standard machine here. What we're going to do, we're going to create that. We may want to power on, but it might not like the underlying hardware. You might say that the resources are not enough. So what we're going to do, we're going to configure fault tolerance on one virtual machine. Its copy will be created automatically on the other virtual machine. Then what we're going to do is we're going to test. We're not going to power that on the virtual machines. We're going to test. We're going to crash that. Whichever hypervisor has the active virtual machine, we're going to crash that virtual machine hypervisor. We're going to crash that hypervisor. We're going to check that. So the active virtual machine will be called primary, right? Primary, and the other one will be called secondary. Once the hypervisor crashes, what will happen is that automatically the secondary should change its name to primary. What we're going to see in our lab. This means that the fault tolerance is actually working. But because of the lack of good hardware, we would not be able to power it on. It's a very sensitive process, and it's gonna take like a certain more resources which we don't have. But whatever we have, we're gonna try to do it. So these are some of the prerequisites of fault tolerance. Increase the memory of physics side 1 and 2. from 4 to 8 GB. Okay, we have increased it to 6 GB. Let's see if this is also good for E6i, not 1 and 2. It's gonna be E6i 2 and 3. 4 to 8 GB. Although we have 6 GB is also okay, but more RAM better. Have two data stores available, one for primary machine and one for secondary machine. Okay, we have three data stores available actually. Check. Turn on EVC. Check. We just did that. Vmotion must be working. I am assuming it is working because I didn't mess up anything, and last time we checked, it was working. Let's have a new network adapter and new VM kernel port with FT logging enabled. So remember that we created a VM kernel port for vMotion. Now I'm going to create a VM kernel port for fault tolerance as well. Let's enable FT on both hosts. Choose any VM shutdown that is on shared storage. Check which data store first VM is. Okay, troubleshooting is if there are errors, then make sure that VM has 1 GB memory for its working. Guys, it's a sensitive lab, so it might just scream at us that, hey, we don't have enough memory. So that's why virtual machine should have 1 GB memory or even less. Please check which data store it is on. Turn off FT and then change the. If you had to change the memory, then you have to first turn off FT. Suppose you were going through the FT process, then change the memory and then turn on. You need to have HA and EVC enabled, otherwise FT will not work. This is also. Suppose your EVC and HA or EVC or HA, any one of those is turned off, disabled, then FT will not work. If we are still low on CPU and memory according FT, then we can visit admission control feature and HA and turn it off. So HA we cannot turn off, but admission control feature of HA, yes. So we already turned off admission control. I just turned it off, right? So what needs to be done is this. I create VM kernel port on EXI 2 and 3 for FT logging, just like for vMotion. So I'm going to do that now. I'm going to go to I'm gonna be on ESXi 2 first. I'll go to the configure area of ESXi 2, and then I'm gonna go to the VM kernel adapter area of ESX and I and 2. Just like we created for vMotion, we're gonna create it for this as well. We have to have dedicated IPs. For vMotion, we used IP 5 and 6. So for fault tolerance, we're going to use 7 and 8 IP. Right? I'm going to create a VM kernel adapter to enable fault tolerance on E6i2. I'm going to do the same thing then for E6i3. So I'm going to go to add networking on E6i2. VM kernel network adapter, yes, and we're configuring this fault tolerance. So next. We will be creating new standard switch just like we created a new standard switch for vMotion following the vendor best practices because we do have enough network cards. That's why we're gonna dedicated traffic for fault tolerance as well on its own 2 network cards, right? New standard switch, I'm gonna click next. Then I need 2 more adapters. I'm just gonna click assign, just like in vMotion. I'll go for vendor best practices, going to network adapters and click next. Network label is FT. So it's fault tolerance that we are configuring here. Rest of the configurations we don't need to do other than that. This is obviously the most important. We need to configure fault tolerance logging. Right, so FT above name and fault tolerance here. We go next. We decided that we're going to give the IP. I'm going to go for that 192.168.200.5 and 6 we gave for vMotion, so 7 or 8 and 8 we're going to give for this. So 255.255.255.0. Don't want to override the gateway, which is okay. So I'm going to click next and finish. I'm going to do the same thing for E6i3. And networking, yes, Vim kernel network adapter. Next. We're going to new start switch because we have enough network cards. We're going to click assign adapters. 5.6. Next. Then we go for FT and we go for fault tolerance logging. We decided for separate static IPs 192.168.200.8 7 and 8, right? 255.255.255.0. Although HTTP based IPs could also work, but best practice to give static IP for the critical ones. Next. Finish, right? So fault tolerance has been enabled on the 2 hosts that we have. The rest of the features we already confirmed that we are okay with. And all we need to do is enable fault tolerance on the virtual machine. We don't need to enable it on the host. We just need to enable it on the virtual machine. So I'm going to choose one empty virtual machine and then I'm going to go for fault to the and rents. So I would just going to randomly go for any one powered off virtual machine. I need to know which hypervisor it is on. It is on 03, so its partner will be created on 02. Second thing is which data store it is on, right? It's on DS2. So it's a secondary virtual machine. I would just choose data store other than DS2. It's on hypervisor 3. It's on data store. Okay. I'm going to right click on this virtual machine and there's the fault tolerance. Turn on fault tolerance. It says here which store you want to put your secondary VM disks on. I know that I need to put it on a data store other than DS2, so I'm just going to go for DS1, yeah, select, and then click next. And the only other data store available is 2 because it is on 3, right? On 3, right? Yeah. 2. Next. The secondary will be on 2. I'm going to click finish. Okay, so you can see that other virtual machines icon is kind of light blue or white, but this is dark blue. You can also see one more thing. It's primary written here now, and it actually shows 2 data stores. But where do I see the secondary? I'm going to go to the view of hypervisor. On the hypervisor level, I want to see the virtual machines. If I go to E6i2 here and this one, VMs. E6i2 VMs, I see here, oh, secondary has been created on E6i2. Okay, good. E6i3, if I go, its primary is created on E6i3. So that's very good. So far, so good, right? You can right click on the virtual machine that has been configured with fault tolerance now. So if I go to fault tolerance, so it actually shows suspend fault tolerance, migrate secondary, test failover. All these options are there, but this is out. This is available when it powers on, but attempt to power on, but it's not really compulsory. I just want to show. Mostly in production environment, it is definitely compulsory, but I want to show that even if the virtual machine is on primary and I crash this 6i3, then this machine on secondary will automatically become primary. It will change its name from secondary to primary. That's what I'm going to show you even while they are shut down. But I'm going to attempt to start it because of the underlying RAM so less. Still going to go ahead and power on. And if it doesn't give any error, and there you go. Okay. Available memory resources in the parent resource pool are insufficient for the operation. Although I gave 6 GB here, still is showing less memory, and the FT is kind of stubborn. It needs a lot of memory. But our purpose will still be achieved that fault tolerance works or not. When primary is living on E6i3, which I'm about to crash now. So E6i3 will not be available. So E6i2 has secondary VM, right? Moise says powered on for me. Oh, this means you, Moise, what RAM you have given to E6i2 and 3? 6 or 8?
6.
Okay, your hardware must be much better than mine. Okay, that's very good because if it is 6, then if you right click here and it's powered on, I mean, if it's powered on, then you right click here and go to fault tolerance, so then test failover should be enabled. Is it enabled for you?
Yeah, it's enabled.
Okay, good. So test failover just tests the failover, but I'm going to show you the failover even when it is shut down, that it does failover. So guys, again, the experiment is, does fault tolerance work? How do we prove that? E6i3 has primary. I'm going to crash primary by powering off 6i3 from here. After that, what are we expecting? E6i2 has the secondary. So as soon as we lose the primary hypervisor, secondary E6i2 based virtual machine is now showing the name or the label secondary should automatically turn into and show primary here. That's what we're expecting. It means that failover happened even when the virtual machines were shut down. Okay, so I'm going to take out the primary hypervisor. I'm expecting it's going to be off, and I'm expecting that E6i2 based virtual machine will stop showing secondary and will start showing primary automatically. Right, so I'm just going to go to E6i3. Yes, the primary is here. So I'm going to crash this E6i3. I'm going to go here and power. Power off is unsafe way to power off the machine. It's like pulling off the cable, but we are, pretending that disaster strike and it turned off automatically, right? I'm gonna power off this provider.
I do it with the VM powered on, or should I power off the VM before doing that?
You can keep the VMs powered on and do the same thing I'm doing. And in both cases, it should automatically, secondary should automatically become free.
Okay. Okay.
So E6i3 is there. It's powered off. E6i2 is still on. Let's see if VCSA detected this. Okay, it did. Seems like it did. So E6i3 now is detecting not. So it says here, it seems like it is detecting that and disconnected primary. Yeah. If I go to E6i2, let's see if it has, it still says it's secondary. So the status on the dashboard is still not updated yet. So I'm just going to refresh that, keep refreshing that. and the background processes are running, and they are trying to determine what's going on. It might take time as well in our limited hardware. But what I'm expecting is that the ESXi2 based virtual machine will change its status from secondary to primary. One day, Monday or Sunday, it's going to do that. It's supposed to do that fast, but I don't think it's in a mood today. Door cluster, if I just refresh that, or maybe refresh the browser or sign out, sign in as a sign of. Okay, it still shows secondary.
Change to primary on ESSi2, but still, I'm still having like the status alert. Is it normal?
Well, obviously one machine is gone, so one full hypervisor is gone. So yes, it's gonna give you alerts, which is okay. But did the secondary change to primary in your case?
Yeah, yeah.
Okay, so it worked for you, but it's just taking time for me. But normally it will just works. I'm just gonna refresh the whole browser. And okay, so well, it shows the primary and secondary, which is actually what HA does. So instead of changing the status, and yeah, one more thing what I should have done is that I should have put a I should have done an affinity rule for these two machines that these two machines cannot be on the same. But you know, another thing happened, and that is HA, which I was not really expecting at this time. Okay, so Moise has shared a screenshot which shows that the secondary, which used to be secondary, is now primary. This is what is the expected result, but mine one actually is coming from some other planet, so it's showing something else. It's very good, Moise, that you were able to do that and show that as well. I'm just going to sign out from here and sign in again just to explain to the dashboard that, hey, give me the result I was expecting. Administrator add vsphere.logo. 123.123. Are you kidding me? So guys, what happened? What happened here is, so ESXi3 is still down, ESXi2 is still up, but something else happened that I was not expecting. HA is still enabled, right? So high availability is supposed to move restart the virtual machine of a down hypervisor on the other surviving hypervisor. So that HA exactly worked, and it started the machine on the other hypervisor. Now, if the affinity rule was there, then it would not have been able to do that, and it then would have changed the secondary to primary, seeing the result. But right now, it just moved the two machines together, which is not supposed to be the fault tolerance way of doing things. As because of the affinity rule not there for these two, so these two got together in one machine. So that is totally unexpected, and not sure what kind of efficiencies my DRS and HA are together showing me. But yeah, secondary is supposed to change to primary. Seriously. Right. So, okay, there's one more thing. If I make it on, it's already shut down, so how can I make it further gone? Maybe I could delete it. Or I'll make it unavailable. It's shut down, so it's kind of unavailable anyway. How would I make it? There's a hard stop. From stop beam operational. Stop beam operation forcibly terminates all processes that currently run on the virtual machine and powers off the virtual machine. It is powered on off. Seriously. With this operation can result in a loss of unsaved information. Blah 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 blah. I did yes because seriously, it was already off. So yeah, guys. Now what I was supposed to say is, hey, fault tolerance works. Okay, Moiz followed the exact same procedures, and yes, fault tolerance worked for him, and he showed the screenshot there. So yes, fault tolerance works. But in my case, I can say HA works. So HA woke up out of nowhere and it started working, and it just restarted, or it moved or placed my virtual machine on the other hypervisor, which is something that I was not expecting. Seriously. Okay. So yeah, FT guys, you when you're doing the lab, just follow the exact steps, and likewise, you'll get the same results. Somehow, maybe I've messed up something somewhere. But instead of fault tolerance, the HA labs kicked into action. HA personality kicked into action. The steps are exactly the same. Okay, so Pragnesh says, can do the lab. Yeah, I understand that this is something that is out of, I think, even VMware's hand. And we're just trying to figure out what to do. VMware is just changing. Oh, dude, that's right. Okay. Yeah. But next, many labs you will still be able to do, Pragnesh. There are other labs. Some labs are pretty sensitive to hardware, and other labs you will be able to do. So, okay, guys, this is it.
The
Yeah,
16 GB is not enough for this lab.
no, not for this, and one more lab, which is vSAN, which is very critical, but not enough for this lab. So, but obviously, seeing vSAN as well and this one as well, and try to understand and make your notes for the job interviews later. So that would still be very beneficial. Okay, guys, so this is it. Go ahead and upload the screenshots since we didn't have a break, so I'll finish it here, but we're gonna start doing some more um, labs in next class. Yeah. So Nathaniel says I have a question. Yeah.
Sir,
Hello.
I am a little bit late. I am with a problem. Can I show my screen so that you can
Yeah, sure.
see? Can you see? Okay, here I have got a problem. My VMwares are inaccessible, here inaccessible. Storage here, they're inaccessible.
Okay, so this is the first machine. Let's go down to the Windows icon. Do you see the Windows icon there on the left side bottom?
In the Windows,
Yeah,
here,
down. Yeah, this one.
start.
Yeah, click.
Okay.
And then go to Server Manager on the right, the big blue box that says up, a little up. Yeah, up.
Server Manager.
So, and close this. Yeah, this one. And then go to File and Storage Services on the left.
Okay.
Oh, iSCSI, yeah. You scared me to death. So iSCSI connected to node 1, to node 2, to node 3. Okay. You're supposed to be good. Then you have to connect one by one to all these hypervisors and then check. So I'm going to give you an example of one. So open the Chrome tab, go to Google Chrome and open another tab and connect only to E6i1 from the browser. From the browser. Yeah, this one tab. Is it? Yeah, it's E6i1. So root and yeah. So you have to check that through all the other hypervisors and then restart the whole environment. Okay, so when you go to storage, why do you see 2? You don't see 3.
I don't have 3. I've been
Go to
using the
adapters.
2.
Go to adapters.
Adapters.
Go to software as SCSI. Although the 2 data stores are showing, so it's good.
This one?
No, the other one. Software as SCSI, yeah, this one. Enabled, go down to the bottom. 162, 10, 3260. Yeah, it just shows 2. So cancel this. So this is good. Cancel. And if you go to the rescan and refresh, click rescan, click refresh. Go to the data stores.
Wait, yes?
Go to the data stores. Now 2 lawns are showing here, which is good. Okay, now connect to the second hypervisor and third hypervisor and check if the 2 lawns are there. Down. Yeah. Okay, go to E6i2 and disable lockdown mode. You will be able to enter, otherwise you won't be able to enter. So go to E6i2 and press F2, FN F2 and disable lockdown mode.
F2 then?
Yeah, login. Root, password, yeah, login. And then go just one key down, configure lockdown mode, enter.
Okay.
Enter. Spacebar to uncheck. Yeah, and then press enter. Now go back to Win01. No, it's okay. Go to the other machine, Windows machine. Mouse. Alt tab.
The control?
Take the mouse. Control Alt. Go to the Windows machine. Login. Storage. And adapters. No, data stores. Hey, you don't have that here. You need to configure it. So
Here I have to configure it.
yeah, configure in this and the A6i3, then it will appear there.
Okay.
So
Okay.
refer to the
So
videos for that and do the
this
live.
will be okay then.
Yep, it should be okay then because it
Okay.
has to be preparing on all three.
So I did AXI 1, but not 2 and 3.
Yes, that's the vision.
Okay. Thank you. Thanks so much. I'll do that.
Cool. Guys, so upload your screenshots to the folder that I haven't created yet. So I'll be creating.
So just one question.
Hmm?
What will happen if we start in these parameters? If we restart the exercise 3, what will happen to the FT fault tolerance? Will be the behavior of fault tolerance? Will it still keep the primary on exercise 2?
So the secondary will stay as primary, and side 2, when it comes back, it will be the new secondary.
Exercise 3 will be the new secondary.
Like side 3 will stay as the new primary, and the one on side 2 that was previously primary should become secondary.
Didn't get you. Now we have, or else we were having the primary on exercise 3. We shut down exercise 3, and the secondary on exercise 2 became the primary. So now if we start or restart the exercise 3 now, what will happen? Will the VM on exercise 3 become the secondary, or it will go back to the previous stage? I mean, become primary.
So ASXi3 had the secondary before, right?
Exercise 3 has the primary before.
And
And we shut
ASXi2
it
had the
down.
secondary. Then ASXi2 had the secondary before, right?
Yes.
So ASXi2 then becomes the primary. So it will stay as primary even if ASXi3 comes back.
Okay. Okay, thank you.
So I'm just gonna create that quickly on the folder. I'll just show it here now. It's 1301 and visible to students. Save. So hopefully you're able to see the 13 now. And I'll create assignment. And, save and please upload. And that is one. Yep, that's the correct date. Now it should be accessible. Go ahead and please upload. Hopefully you're able to see that. Yeah, you should be able to see that. And then I'll be, uploading that. So go ahead and upload, and bye bye. See you next week.
Good night.
All right. Good night. Bye bye. And view and download, save. All right. Stop the video. My kids are screaming.